Hi, we are going to solve this given oblique triangle. In order for us to do that, we could either use the law of sines or law of cosines. But the use of those formulas depend on the given measurements. For this given oblique triangle, we are given with one side, we are given with one angle, and another angle here. This is an example of an AAS or SAA triangle. With this situation, we are going to use the law of sines. The law of sines will allow us to solve the unknown measurements using the ratio or the proportion of all ratios involving sine of an angle and its equal and its opposite side. For this given oblique triangle, we could label this as A. That would mean the opposite angle to that is angle A. Let us label this as angle B. This is angle C. It would mean this is side C and this is your side B. So we are given with two angles and we have one side. We're going to use the law of sines using the ratio of sine of an angle to its opposite side. So you could have here a formula, sine A over side A equal to sine B over the measurement of side B, and it's equal to sine C over the measurement of side C. But before we could use this formula, the first thing that you could do is actually to solve for this unknown angle here, which is the measurement of angle C. The measurement of angle C can be solved by subtracting the two given angle measurements from 180 degrees. This is in connection to the triangle angle sum theorem. So we are going to subtract those two from 180 degrees. So you have 180 degrees minus 41 degrees minus 53 degrees. Therefore, the measurement of angle C is now exactly equal. We will not be using approximation. That's exactly equal because the two given measurements for angles are exact. So to solve this properly, you can use this calculator here. So you'll have 180 degrees plus 41 minus 53 degrees. So you have exactly 86 degrees as a measurement of angle C. So exactly 86 degrees. Now, we are done with the measurement of the first angle. We are now going to proceed in measuring side B or side C using this formula for law of sines. To do that, let's try to input all of the values here. So your angle A is 53 degrees over side A, which is 14 units, is equal to sine B, which is 41 degrees over the unknown, the first unknown. And finally, you have your sine 86 degrees over the second unknown, side C. Let me increase this portion here for more spaces. In solving the sides, we are going to pick the ratio with all given measurements. I'm talking about this pair here. So we will be pairing these two ratios, and then we are going to solve for that. Now let's start with side B. What we're going to use here is the fundamental law of proportion, or your cross multiplication, if you may. So we will have here cross multiplication. We will have B and sine 53 degrees will be equal to 14 times sine 41 degrees. Then, we divide both sides by sine 53 degrees. Cancel this out. Do that same thing on the other side, but it cannot be cancelled. In short, the measurement of b is the entire expression of this. Let us use the calculator that we used earlier. Let's try to input the numerator at once. So you could have your parentheses, 14, then sine 41. Close that and close. That's for your numerator. Divide by sine 53. We are doing this so that we could be assured of proper operations here. So push equal sign, you will have 11.50064, so on and so forth. Let's round it off into two decimal places, and by doing that, we are going to use approximation. So we have approximately equal to 11.50. So that's approximately equal to 11.50. And since it's a side measurement, that's 50 units. Please, you need to also place here the 0 for two decimal places because it's significant, because it's not exactly 11.5, but it is actually a rounded off value. Now, let's solve for C. Also, you might think of pairing this second ratio to the last to get the value of C, because we already have the value for the measurement of side B. But since B is already a rounded off value, let us use the given with the exact measurements. So let's try to pair the first ratio to the last, because this is what is. So by cross multiplication, we will get a result of C sine 53 degrees is equal to, we have 14 and sine 86 degrees. And same as earlier, divide both sides by sine 53 degrees, cancel that out, do the same thing on the other side. In short, C is computed as this expression. So let's try to use the same calculator. So again, parentheses, 14, you have your sine 86 degrees, close, close, divide by sine 53 degrees. Push equal sign, you will have this result. Rounding it off into two decimal places, you will get 17.49. Or that's approximately 17.49, and we use here units. Now we are done solving the last unknown measurement. Because our given is AAS, we are solving for the remaining angle and the two side measurements. Before we end, we could also check whether our answers are correct or not by looking at the perspective that the side opposite your largest angle should be your longest side. And conversely, the side opposite your smallest angle will be your shortest side. For these two angles with the last one that we have solved, C is your largest angle, 86 degrees versus 53 degrees versus 41 degrees. It would mean that side C is longest. Let's check. A is 14 versus 11.5 versus 17. This is our longest side. On the other hand, 41 degrees, that's angle B, is your smallest angle. It should be given that side B to be your shortest side. 14, that's A, versus 11.5 versus 17.49. It also is that. This is how we solve an example of an AAS or SDA oblique triangle.